we go. So we are live. So now we change the camera and get focused on what the class is going to be about. Then I'm sharing my screen with the questions that you had to answer. So the first question was, for the following curve, find the velocity vector at the given value of t. All you have to do in that question is take the derivative, take the appropriate derivative, and plug in the value of t to find out what it is. So first part of the answer, you put that here. Second option is here. If r prime is 0, you choose the second option. If it's not 0, then you plug it in and you write down up there what the answer is. How do we work out this problem? So that's velocity at a given point. R of t is negative 3 sine t. 3 sine t sine of t over 2. And the way you answer a question is first writing down what the question is. So you can't answer a question that you're not seeing. You write down the question, then you give the answer. And so you get r prime of t, that's the derivative of a vector. We learned the derivative of a vector, you need to take the derivative of each of the functions. Derivative of negative 3 sine t is negative 3 cosine t. Derivative of 3 sine t is 3 cosine t. And this is chain rule, that's 1/2 cosine t over 2. And then r prime of pi, that is negative 3 cosine pi, 3 cosine pi, 1/2 cosine pi over 2. You lose nothing by writing that down before seeing what the answer is. Cosine of pi is negative 1 times negative 3, that's 3. So this is negative 3. Cosine pi over 2 is 0. In this case, that's what you get as answer. What the second question was about was indefinite integral. So find the indefinite integral. Of r of t equals t e to the t I plus t cubed sine t to the 4th j minus 2t over root 2 over square root of t squared plus 3k. And the rule we said was you need to integrate each of these functions separately. And so the integral of r of t dt equals integral of t e to the t dt I plus integral of t cubed sine of t to the 4th j integral of negative 2t over root t squared plus 3. Okay. And when you integrate this first one, you get t e to the t minus e to the t. And that's going to be plus c1 times I. That is a constant of integration for every integral you take. When you integrate this chain rule, that's minus 1/4 cosine of t to the fourth plus c2j, then minus the last one here. When you integrate this, you know, when you take the derivative, you get 1/2 because of the square root. So we are missing the 1/2 here. So that's going to be 2 square root of t squared plus 3 plus c3 times k. And now if you want to combine those things, you can do now that this is t e to the t minus e to the t I minus 1/4 cosine t to the fourth j minus 2 square root of t cubed of t squared, sorry, plus 3 k plus a vector c, where c equals c1, c2, c3. That's how you would answer that question. Now, in the next question, you had a derivative of a vector and then you had an initial value. The goal in this class is to learn you how to apply the theory, not just finding an answer, but apply the theory. So question 3. Find r of t for r prime of t equals 1, 2t, 5t to the fourth, r of 1 equals 8 minus 2 minus 6. So the theory says r of t integral is an indefinite integral first. We could say this is integral from 1 to t right away. R prime of t dt, or r prime of s if we want to be sure we don't get lost with the notations, r prime of s ds plus r of 1. That's the same thing we did when we started at 0, where we gave you r of 0. You apply the same formula starting at 1. And so this is going to be integral from 1 to t, and then r is 1, 2s, 5s to the fourth, ds plus 8 minus 2 minus 6. That's equal. Integral of 1 is s from 1 to t. Integral of 2s is s squared, 1 to t. Integral of 5s to the fourth is s to the fifth, 1 to t. And then you add 8 minus 2 minus 6. That gives you t minus 1, t minus 1 plus 8, t squared minus 1 squared minus 2, t to the fifth minus 1 to the fifth minus 6. And that is equal to t plus 7, t squared minus 3, t to the fifth minus 7. That's it. And what you need to learn there is to know that when you have an initial value and a derivative, the function is obtained as integral from the initial value to t plus the value at the given time. Now the next question was a definite integral of the kind we just computed. So we have integral from 0 to 3 of t e to the t times 4I plus 6j minus 9k dt. And here the thing was for you to understand that a constant can get out of the integral. So that's all a constant 4I plus 6j minus 9k, all of that times integral from 0 to 3 t e to the t dt. And you just have one integral to compute instead of 3. So that's 4I plus 6j minus 9k. And that integral is t e to the t minus t by parts 0 to 3. And your final answer is going to be 3 e to the 3 minus 3 times 4I plus 6j. And that's because when you plug in 0, you get 0, okay? Minus 9k. So that's 12e cubed minus 12I 18e cubed minus 18j minus 27 e cubed minus 27. Okay. And also a thing to know is that you needed to put the parentheses around the coefficients, not around the vectors. Because when you don't put parentheses here, it's only 12 that is multiplied by e and by I, and you can have numbers plus vectors. So it's a serious mistake if instead of putting the parentheses around 12e cubed minus 12, you put them around I. And it happens you're adding vectors and scalars. Any questions up to now? Is there any question? Now let's look at the question number 5. And question number 5 starts what we call the length. So find the length of the curve. And I think this one is exactly the one that we solved in class the other day. So it's cosine t plus t sine t sine t minus t cosine t. And then we say 0 is less than t less than pi. So that's a curve that we have. We need to find the length. First, you need to know, get first the formula, answer. The length is the integral from 0 to pi, which is the given interval of the magnitude of r prime of t dt. Give me that formula. You get credit for knowing that formula. Then you find r prime of t. You get credit for finding r prime of t. So that's negative sine t. And the derivative here is going to be derivative of t is 1 times sine t. It cancels this sine t. Then derivative of sine is cosine times the t. So it's going to be t cosine t. And you take the derivative of that. Then when you start here, the derivative is going to be cosine t. Then minus the derivative of t times cosine. It cancels the other cosine. And then derivative of cosine is going to be negative sine. So it gives you t sine t. So that's what the derivative of that vector is. Adding this derivative of these two and the derivative of these two, you get that. And so that's r of t. You get credit for getting that correctly. And then you find the magnitude of r prime, for which you get credit as well. But if you don't take time to compute that separately, I don't see how to give you partial credit if you got nothing correct. So this is going to be square root of t cosine t squared plus t sine t squared. And that is square root of t squared cosine squared t sine squared t. That is t, because cosine squared plus sine squared is 1. So this is integral 0 to pi of t dt, which is equal to t squared over 2, 0 to pi. And in this example, that's pi squared over 2. So the next question is exactly same as this one, so I'm skipping it. The trajectory says find the speed. The speed is this, what I just computed here. Absolute magnitude of r prime is what we call the speed. And then find the length. So find that speed, put in the integral and compute. That's the same thing that is in the next problem you had there. The only difference is that there you had some exponential functions, which will also integrate properly into the same thing. So I'm moving to the next question. Consider the object that is moving along the equation. Find the tangential and normal components of the acceleration. Important. So you say here moving object with position r of t equals 15t squared. Find at and an. First comment on the mistakes that I have seen. At is a number, an is a number. They are not vectors. So you can't give me a vector as an answer to this question and expect credit. So how do we find them? We had many formulas for this. We had at, easiest is a dot t. This is always going to be the easiest of the two to find. And so to get that, you need to find a and you need to find t. So here you got v of t equals r prime of t, and that is 15, 30t. Magnitude of v of t is 15 square root of 1 plus 4t squared, which is square root of this squared plus that squared. And so we have t equals v of t over magnitude of v of t. And that is this factor over that, the 15 cancel. No, that's 1 over root 1 plus 4t squared, 2 over root 1 plus 4t squared. Now, when you take that t, you need to get the a. A is derivative of v. And the derivative of v, that's 0 and 30. So at is a dot t. And that is 0 times 1 over root 1 plus 4t squared plus 30 times 2 over root 1 plus 4t squared, which gives you 60 over root 1 plus 4t squared. That's at. Now tell me what we do for an here. The first formula is a dot n, but to use this formula, you need to find n first, all right? And to find n, you know that n is the derivative of t divided by its magnitude. And with the formula of this that is given, it's very hard to take that derivative. So you want to use the alternative formula. What's the alternative formula for an? Nate?
Is it the magnitude of a cross k over k cubed?
A cross?
Is it k?
And what would be k?
One over r.
That's a number. And you can cross product a number and a vector.
Isn't it A cross V over magnitude of V?
Correct. And so because we already have magnitude of V, we have A and V, we have phi. And I said to use this formula, all you need to do is just add the extra 0 to A and V. So 0, 30, then add 0 there, and V, give V as 15, 30t, and add the 0 there to be able to compute the A cross V. And that's going to always be 0, 0, and the last one is going to be negative 30 times 15. How much is that?
$15.
Is that right?
Yeah.
So that's it. And so magnitude of A cross V is absolute value of magnitude of 0, 0, negative 450 over magnitude of V, which is 15 square root of 1 plus 40 squared. And this is equal to 30 over square root of 1 plus 40 squared. So that's the normal component of the acceleration. Any questions? You need to be prepared and know that you have to answer questions of that kind. Is there any question on this? Now in this problem, we have a problem where we are given T and N, and we need to find B. And B is T cross product with N, and that's the reason why I write them like that. So T, this gives you B equal, you cover this and you get that. So it's going to be 0 minus minus plus 17 sine T over 13 root 2. Then you cover this, you get 17 cosine and the minus, so that's minus 17 cosine T over 13 root 2. And then the last one gives you 7 sine squared plus 7 cosine squared, that's 7. Then you can make sure that if you do the dot product of this and that, you get 0. And you do the dot product of this and that, you get 0 as well. Any questions? There was a question about the torque. The formula of the torque, what is it? Tau equal what? Sydney? Is she here?
What I got was negative dB over ds times n. Is that correct?
Over ds time,
N.
not times, but dot n.
Oh, dot. Yeah.
That's okay. And dB over ds is actually b prime divided by the magnitude of v dot n. That's what it is. So you take the b that is given, that you got here, take its derivative. That's negative. Derivative of this vector is going to be 17. We can actually 17 cosine t over 13 root 2. 17 sine t over 13 root 2, 0. That's it. Dot product with the n, and that n is negative cosine t, negative sine t, 0. And then over the magnitude of v. Okay, so this that will be negative cosine square minus sine square, and they add up, and then get 0. So here it's going to be negative 17 over 13 over 2, and the magnitude of v. I'm just writing that like this because in this problem, the magnitude of v is not given to you. So in another problem, it won't be given, and you have to find it. And the magnitude of v here, r, is given as 16. So here in this problem, you have r of t equals 7 cosine t, 7 sine t, 17t. So v of t is negative 7 sine t, 7 cosine t, and 7. That's it. That's why the magnitude of v is square root of, that'd be 7 square plus 7 square cosine, 7 square sine. It's going to be 7. This is 17, okay? And so that's going to be 49 plus 17 squared. And what's 17 squared? Anyone to give us quickly what this thing gives us?
289.
Huh?
17 squared is 289.
I can't hear you.
17 squared is 289.
I don't know why, but it seems your microphone is having issues. So for me, it doesn't sound. That's fine. I'm just gonna compute that. So that gives you 338. So that's what you have here. That's it. All right. Any questions on this? Okay, if there is no question, we move forward. And we look at what is called question 8. So the curvature of f of x equals 14 e to the x, and find the point where it is maximum. And the maximum. That's what the question says, and nobody actually answered completely that question. It has 3 pieces. Find the curvature, 1. 2, find the point where it is the maximum. 3, find the value of the maximum. And as answer here, you're going to use the formula. What's the formula for the curvature? To do that, first, you're going to write down here r of x is, and then the y is 14 e to the x. That's what it is. And what is the formula for the curvature? Or if you don't want to get confused, you can put these here to stay consistent with the lecture.
Isn't the magnitude of t over the magnitude of v? T prime. Or
There's another formula, because using this formula, you will have to find t, and then find t prime, and then find its magnitude. And the form of the function is already indicating that finding t prime is going to involve a lot of roots, and then finding the magnitude after that is going to be even harder. So that's an indication for you to go for the alternative formula. What's the alternative formula for it?
Is it V cross A over magnitude of V to the third?
Something is missing on top there.
Magnitude of V times cross there.
Magnitude, because this is a number. Over
Magnitude of V to the cube.
that's the alternative formula that we had. And that's ultimately what you need to use in this case if you want to avoid trouble. And so that said, what you want to do is make sure that you just add that extra zero, get t 14 e to the t and 0. And then your v of t is going to be 1 14 e to the t, and your a and n0 is going to be 0 14 e to the t 0. Your v cross a is going to be 0, then 0, and then negative 14, and then, sorry, 14 e to the t. Magnitude of v cross a is 14 e to the t. Magnitude of v is square root of 1 plus, what's 14 squared? Is that true?
It's 196.
Good, e to the 2t. So all of that leads to say that the curvature is 14 e to the t over 1 plus 196 e to the 2t raised to the power 3. Now the next part of the question was, where is this curvature maximum? How do we find the maximum of a function? Yes,
Its derivative is equal to 0.
set the derivative equal to 0. That's what you need to do. The derivative of this is derivative of, that's a quotient rule. So that's 14 e to the t times 1 plus 196 e to the 2t to the 3 halves minus 3 halves times 2 times 196. Chain rule, 3 halves, 196 times 2, e to the 2t, divided sorry, not divided yet, but times 1 plus 196 to the 3, e to the 2t to the power 3 halves minus 1, which is 1 half. So And so this is just the derivative of that denominator using the chain rule times the numerator, 14 e to the t, divided by the square of the denominator. Are we correct? So that's 14 e to the t times 1 plus 196 e to the 2t minus 3 halves and 2 they cancel, so 3 times 196 e to the 2t now 3 halves minus 1, 3 minus 1 half, that's it, 5 halves. Now, so and if you want to set this equal to 0, that is going to mean that this is 0 because e to the t cannot be 0. So that implies 1 minus 2 times 196 e to the 2t equals 0. And then you can see we have only one solution. That's e to the 2t equals 1 over 2 times 196. And so t is 1/2 natural log of, so minus 1/2 natural log of 2 times 196. So that's the point where it's maximum. So, but I'm going to keep this quantity 196 e to the 2t is equal to 1/2 from here. And e to the t is 1 over this number here was the square of 14, right?
Yes.
So that's going to be 14 root 2. So 14 e to the t is 1 over root 2. I'm just taking the values that I need here. That's this. So we can find the maximum of that function is Calc equal 14 e to the t, 14 e to the t, that's 1 over root 2 divided by 1 plus 196 e to the 2t. 196 e to the 2t, that's 1/2 to the power 3/2. So that's 1 over root 2 times 2 plus 1, that's 3 halves, to the power 3 halves. So that's going to be 2 over 3 root 3, if I'm not mistaken. So that's what you would find as the maximal value of the curvature in this question. Any questions? Now, the other question was here. Find the radius of curvature and write down the equation of the circle. And so we have r of t equals t 5t squared. And the radius of curvature is 1 over the curvature. And the curvature we just found is the magnitude of v cross a over magnitude of v cubed. You can just use that quickly. So r of t is modified as t 5t squared 0. So v of t is 1 10t 0, and a of t is 0 10 0. A cross v, or v cross a, equals 0 0 and 10. So magnitude of v cross a is 10. Square root of 0 squared plus 0 squared plus 10 squared. So magnitude of v is square root of 1 plus 100t squared. So kappa is 10 over 1 plus 100 t squared to the power 3 halves. And the radius of curvature is 1 plus 100 t squared to the 3 halves over 10. Radius of curvature at 0 is therefore 1/10. And r of 0 is 0 0. So that's the center of the circle. So you have x minus 0 squared Now, the next questions were mostly about our last lecture. Question 10. Find v of t, magnitude of v of t, and a of t. And then you are given r of t, 3t plus 7, 5t minus 9, 7 plus 3t. V of t is r prime of t. That's a derivative, so that's 3, 5, 3. Magnitude of v, that's square root of 3 squared plus 5 squared plus 3 squared. 9 plus 9, that's 18 plus 25, 43, right? And the acceleration is a of t, the derivative of v, and in this case, that's 0, 0, 0. That's it. And the next problem was the reverse of this one. Find v of t and r of t, given that a of t equals cosine t, 3 sine t, v0 equals 0, 4, r of 0 equals 2, 0. So v of t is integral 0 to t a of s ds plus v0, and that's integral 0 to t, and I do expect to see this work written down. And a, that's going to be cosine of s, 3 sine of s ds plus v0 is, this is 4, okay, 0, 4, which is equal integral of cosine is sine s, 0 to t. Integral of sine is negative 3 cosine s, 0 to t, plus 0, 4. Sine s, you plug in t, that's sine t. Then you plug in 0, that's 0, plus 0. Negative 3 cosine t, minus, you plug in 0, you get 1, so that's minus minus plus 3 plus 4, that's plus 7. So that's how you get v of t. Then you get r of t, that's integral 0 to t, v of s ds plus r of 0. And that's integral 0 to t, v of s, that's sine s, negative 3 cosine s plus 7 ds plus r of 0, which in this case is 2, 0. Now that integral gives you integral of sine, that's negative cosine s, 0 to t, plus 2. And then integral of negative cosine is going to be sine, negative sine. So it's negative 3 sine s plus 7s 0 to t plus 0. When you do that computation, plug in t, that's negative cosine t, minus minus plus cosine of 0 is 1, 1 plus 2 is 3, and then negative 3 sine t plus 7t. Then we plug in 0, sine of 0, 0. 7 times 0, 0, plus 0, that's it. Okay. And that's how it ends here. Oh, second problem was exactly the same way. Repeated the problem. Now we have question 11 about limits. As t goes to 0, sine t over ti minus e to the 5t minus 5t minus 1 over 7t plus cosine t plus t squared over 2 minus 1 divided by 2t squared k. And the answer is compute each of these things separately. Can use any of the methods that we have used in this class. This is Calc 3, you have done series. So this is limit as t goes to 0. Sine t is t minus t cubed over 6 over t. So that is limit as t goes to 0. 1 minus t squared over 6. And that limit is 1. Limit as t goes to 0 of e to the 5t minus 5t minus 1 over 7t equals limit as t goes to 0. E to the 5t is 1 plus 5t plus 5t squared over 2 minus this 5t minus 1 over 7t. So the 5t cancels, the 1's cancel, and 7t squared over t is limit as t goes to 0 of 25 over 14t, and that's 0. And then you get the last limit as t goes to 0. Cosine of t minus t squared over 2 minus 1 divided by 2t squared equals limit as t goes to 0. Cosine t is 1 minus t squared over 2 plus t to the 4th over 4 factorial minus t squared over 2 minus 1 over 2t squared. The 1's cancel, the t squared over 2 cancel. And so that's limit as t goes to 0 t squared divided remains t squared factorial 2 times 4 factorial. And this is 0 as well. And so your answer is going to be, first limit is 1i plus 0j plus 0k, which is equal to I. Now we had a question about intersection of lines. R of t equals 2t plus 2, 3t plus 5, 3t plus 6, and R of s equals s plus 1, 2s plus 3, minus 3s plus 9. And I said to answer this question, you need to set the components equal to each other. So that's 2t plus 2 equals s plus 1. 3t plus 5 equals 2s plus 3. 3t plus 6 equals negative 3s plus 9. And then we solve this. We get here, we can get that s equals 2t plus 1. And so we take that into the second equation. We get 3t plus 5 equals 2 times 2t plus 1 plus 3. And then we get it into this one, and we get 3t plus 6 equal negative 3 times 2t plus 1 plus 9. And here, what do we get? 3t and 4t, 5 and 5, that's 0. And then t equals 0. And in this one, what do we get? Minus 3 plus 9, 6, they cancel. And then we get also here 0 equal t. So the two equations must be solved by the same number for the solution of the problem to exist. Because these two numbers are same, you say yes, they do meet at that point. And the point where they meet is r of 0, which is this number, equals 2, 5, 6. That's it. Any question? Find the area of the triangle with sides u, v, and u minus v. The area of the triangle is half of the corresponding area of parallelogram. I'm surprised a bit why continuously people here have to compute u minus v for me. The answer is the area is equal to 1/2 magnitude of u cross v. That's it. And then the next question, find the area of the triangle. In this question, the difference is just the points are given to you. That's 1/2 magnitude of OP cross OQ. Projections. This question, you need to understand what's the definition of the vector projection. What's the definition of the projection of U onto V? By definition, what is this equal to? JC? Eric? I'm actually surprised that half of the class did not submit this assignment, which is worth 25 points.
It's U dot V over V dot V times V.
Okay, that's what it is. And that's how you need to answer the question here. The question gives you a V equals 0, 1, 0. U equals X, Y, Z. And you want projection of U onto V equals projection of 3, 6, 1 onto V. So you got to write the two equations. Projection of U onto V, that's what it is. U dot V over V dot V times V equals 1, 3, 6, 1 dot V over magnitude of over V, magnitude of V, that's the same thing, times V. Am I correct? That's what the question is about. You want this projection to be equal to that projection, and which means because the two V's are same, that means you want U dot V over magnitude of V equals 3, 6, 1 dot V over magnitude of V, and these cancel. U dot V is Y, and 3, 6, 1 dot V is 6. So that's it. And that's the last question, and it is 10:45. And we are done. If you have any questions, you feel free to ask. If not, then we say till next time. The test is on Thursday.
See you next one.
All right, see ya.